Hello everyone, I hope you guys are doing well. So today we're going to be talking about this problem and how we're going to connect the Pythagorean theorem, the hypotenuse, and the linear equation y equals mx plus b, and pretty much everything that we talked about up to this point and how everything connects to this concept. So let's take a look at this problem here. So as you can see, you have a square, right? And also you have the diagonal that goes with the square as well. And this diagonal obviously creates a right triangle. And whether we know this is a 45, 45, 90 degree triangle, it depends on the length of the legs. If the length of the legs are equivalent, then we know that this is a 45, 45, 90 degree triangle. However, if the legs are not equivalent, then we know that this is not a right triangle. And as you can see, we have a rise and we have a run. And we have a linear equation, which is also the diagonal of the square, which is also the hypotenuse of this right triangle. So there's a lot of different concepts that are at play here. So I'm going to take this problem and take this visual, this graph, and I'm going to break it down for you guys in a way that's more quantifiable. So we got this right here. As you can see, the length of the square is 8 units height and 8 units in the width, which is also the legs of the right triangle. If we take a look at terms of the rise and the run, this is -8 because we're going downwards, which is negative, which is the rise, which is talking about the up and down of the line. And the run, which is the right and left, and since we're going to the right, is it a +8. So we got the rise over the run, and we also have the y-intercept here, which is -4. And this is the leg of the right triangle, which we can use the Pythagorean theorem then to calculate the length of this green line. So we're going to do all of that, and we're also going to simplify the length of this line to give it the most simple form of the radical. So let's take a look at the slope. Actually, before that, I do want to just talk about this real quickly. The legs of the right triangle are the rise and the run of the slope. Like I said, the legs of the right triangle are the rise and the run of the slope, right? Rise and the run. The line created by the diagonal of the square, is the line that can be represented by y equals mx plus b. So because this is a line on a graph, on a coordinate plane, we can use the slope-intercept form y equals mx plus b to represent this green line, b representing the y-intercept, m representing the slope. And this line is also the hypotenuse of the right triangle. So this green line is also the hypotenuse of the right triangle. The hypotenuse is the side that is the longest of a right triangle, which is also across or the opposite of the right triangle or the right angle, which is right here. So these are three things that we have to understand and the connections that we're making from everything that we've learned up to this point. Now let's take a look at the y equals mx plus b and how to write that. So as you can see, y equals mx plus b is the slope-intercept form. M represents the slope, rise and run. B represents the y-intercept. Y-intercept is where the line intersects the y-axis. So if you look over here, where the green line intersects the y-axis, which is at -4. So let's take a look. So we have slope, which is -8/8. How did I get that? Well, you see the -8, which is my rise, over run, which is +8, -8/8. -8/8 is -1. And then we got the y-intercept, which is -4. Y-intercept is -4. And now we just plug it back into the equation. We got y equals m, which is -1. X plus b, which is -4. And so there we have our linear equation for this line. Now, let's take a look at now the length of the right triangle. So the length of the right triangle is also this green line and can be found by the Pythagorean theorem, which is a squared plus b squared equals c squared, which is represented here. And the reason why I got the 8 and the 8 here is because that's the length of the legs, which is 8 and 8. So I got 8 here, 8 here. 8 squared is 64, 8 squared is 64, is equal to c squared because c is the hypotenuse, which is the green line here. And 64 plus 64 is 128. Take the square root of both sides, and then now we have Square root of 128 can be simplified to 8 square root of 2. How did I do that? Wait, 128 is 2 times 64. 64 is 8 times 8. And 4 times 2 is 8. 4 times 2 is 8. And 2 times 2 is 4. 2 times 2 is 4. And so if I get all of these factors and we multiply it all out, 2 times 2 times 2 times 2 times 2 times 2 times 2 is in fact 128. Put into calculator, you'll see that it is true. 2 times 2 is 2 squared. 2 times 2 is 2 squared. 2 times 2 is 2 squared times 2. So we have a factor of 2 that's remaining on the outside. And when we take the square root of 2 squared, it says 2. Square root of 2 squared, it says 2. Square root of 2 squared, it says 2. And then we got square root of 2 at the end left over. So that should be a multiplication sign. So we have square root of 2 that's left over. And then now 2 times 2 is 4. 4 times 2 is 8. So what we have remaining is 8 square root of 2. But you actually didn't have to simplify it if you knew the conjecture of the 45, 45, 90 degree triangle. The 45, 45, 90 degree triangle conjecture states that if the lengths are the same, and this is in fact a 45, 45, 90 degree triangle, then the hypotenuse will always be the length times square root of 2. The length of the hypotenuse will always be the length of the leg times square root of 2. And so that is the conjecture. So you actually didn't need to do all of this work right here. You could have just looked at this, 8, and then you're like, okay, 8 is the leg, 8 is the x, 8 is the x, therefore 8 square root of 2 will be the hypotenuse. And there you have the hypotenuse and the length. So you actually didn't have to do all of this work if you recognize that this is a right triangle. So that is that. So let's go ahead and answer the 3 questions that we have. So therefore, the length of the line is 8 square root of 2. The length of the line is 8 square root of 2. The linear equation of the hypotenuse is y equals negative 1x plus negative 4. Y equals negative 1x plus negative 4. And this is the constraint. And if you take a look at this graph or this line, it doesn't exceed positive 3, and it doesn't go less than negative 5. You see, it's greater than negative 5, but less than 3. So therefore, it's got to be greater than negative 5, but less than 3 in terms of the x values. So those are my constraints. And finally, this is a 45, 45, 90 degree triangle because the length of the legs are equivalent. And so therefore, this is basically how you solve these types of problems. You could use this line of reasoning and these methods to be able to solve the rest of the problems here. So if you have any questions, please let me know. And I hope this video helped, and I'll see you in the next one. Okay, bye-bye.